Hello, good afternoon, or good morning, depending on where you're coming from. In this video, I'm going to show you how to use Winsteps, which is basically the limited version of Winsteps, a software package which is used for Rasch measurement. So here is the Winsteps, which you can download from winsteps.com. It's freely available. You can analyze 25 items answered by 75 students, and if you are a teacher, I think this is the best choice for you because most of the tests that we use are technically around 20-25 items depending on your class size. So let's get started with Winsteps. I'm using the data and of course the tutorial material provided by Dr. Mike Lineker. So if you want a written reference for today's lesson, you can go through Winstep tutorial 1, which I will provide a link to. So let's get started with this thing. I just clicked on Winsteps, and as you can see, we've got quite a few options here. So I just, these options right here. Sorry, my drawing was not very good, so let me draw again. Technically, these options, all right? It's up to you which one to choose. But for this demonstration, what I'm going to choose is basically, let me just draw this way. Basically, no. Because why I'm going to choose no? Because I'm going to use an already available file. If you have not created your input file yet, you can choose this option here. Which in the next video I'm going to show how to use this one. So let us assume that you already have a file and you want to use for the purpose of analysis. So what do? We just click on no, and it doesn't reply. It doesn't. Okay, just click on oops. Okay, no. Okay, we just click on no, sorry, some technical difficulty here. And we go to file because we want to choose our file. So we want to open a file, and naturally we have to you choose open file here, and from this depository I'm going to choose example 1, which is the knock test from Winsteps tutorial as well. So I just click on this one and we'll get this window. Here we have to click enter a couple of times. So time 1, you see we're asked if we want to specify anything. Not at this stage really, I do not want to specify anything. So I click enter again. As you see here, press enter to analyze. Yes, I press enter to analyze, and this wonderful window just drops down. So what is this window exactly? Technically they're like iterations, and you see here iterations and JMLE iterations. This is nothing really to be worried about if you're a teacher, and the video is actually tailored for teachers basically. So your analysis here has been conducted, and it's pretty good because there are not too many iterations, meaning that the algorithm does not have difficulty figuring out item difficulty parameters and person ability parameters. What is more important to you is basically this window here. So let me just draw some beautiful windows for you. This window right here, okay? This is more important for you. So how do we make sense of this window. Look, there are a few things which I quickly go through, and then I will just move on to further analysis. The first thing that we should remember is the fact that we have reliability indices and separation, which I'm going to highlight here for you. This is reliability for kids or for people, and in this part you've got reliability statistics for items or tabs here. I mean, it depends on what word you would like to choose. If you haven't chosen kid and tab, you will automatically see people or persons and items here. So reliability statistics shows, I mean, there are different ways of interpreting it, but a very simple, easy way to interpret is to it shows how reproducible your people's or person's statistics or parameters are if you give the same test or similar test to the same group of people and others around. That's one way of interpreting it. The other one is how many levels of ability the test has been able to identify. In other words, the discrimination level and their separation. For example, in this test, we've got 1.55, meaning the test has identified 1.5 statistically significantly different groups, meaning that the test has not been able to differentiate between even two groups of students. So that's up to you if it's good news for you or it's not good news for you. It depends on how you interpret it. On the other hand, the items have been separated or differentiated in terms of their difficulty level. As you see, the separation level is 3.73, as you can see here. I just highlighted here for you, and reliability is 0.93, which is pretty high, meaning that you have around 4, almost 4 if you round it up, 4 levels of item difficulty in your data. Is it good news for you? For many teachers, it's good news because it means that you have got items matching all ability levels. So let's now go back to the interface and see what we can do. So I click on this beautiful interface. If you click anywhere, you'll get the same table, or you can just simply click on output tables from here in this toolbar on the top, and you can get the same thing again. So the first beautiful thing that you can output from Winsteps, I believe, is variable maps. You can get it from here, variable maps, or you can get it from tab map or kid map. It doesn't really matter. So let's just go here and just click variable maps, where you get this beautiful map, which now I want to just delete those lines there and open it. So you've got quite a few things here on this map, which is called item person map, or Wright map, after Professor Benjamin Wright, who was the person who developed the map, from what I know. Then you've got people on this side. You see that they're just the name of your students if you have entered them, and if you haven't entered them, you will get something like X's, and every X in this analysis stands for one person, unless something else has been indicated right at the bottom of the table of this table, or this figure, if you will. Now, there are a few things in this figure which we should know and notice. One is the fact that on this sorry, let me just draw a more beautiful figure here. On this side, so here are our students, okay? The students around the ability level of 0, and I will tell you what this thing means exactly, this side, which is our beautiful ruler. So just this ruler means or gives us units of measurement, which are logits. An analogy will be like, centimeters or kgs or kilograms, things like that, but they're not exactly the same thing. It's just an analogy. For example, if a person's ability is zero logits, he's right around the mean of persons. And if it's -1, it falls down by less than 1 standard. This S means standard deviation, 1 standard deviation. If the person is around here, let me say around -1 logit, it's less than 1 standard deviation from the mean, you see. And if the person is -2 logits able, it's around 1 standard, you see the S again, 1 standard deviation, this is the mean, 1 standard deviation far away from our mean. All right. In this analysis, 1 standard deviation is around 2 logits from the mean. Okay. 2 standard deviation, as you see, T stands for 2 standard deviation. It will be quite far away from the mean. So if someone falls 2 standard deviations below the mean, it means that he's really far away from the mean score, and there might be an issue or problem with this person. He didn't learn well, he didn't achieve what he was supposed to achieve, and so on and so forth. Similarly, we have standard deviations for items on the other side of this separating line. So I'm going to choose blue for items. So S is 1 standard deviation from the mean. You see the standard deviation is quite large for persons. And that M here is just hiding. Oops, is hiding basically. But there is an M here if you notice. The M basically means on the right side of the screen means the mean score of item difficulty. So what happens is this item is of high difficulty with 1 standard deviation above the mean, around 1 standard deviation. And these items are about half a standard deviation or so. One of the interesting things about this map is that the logits or the units can apply to both persons on this side and items on this side. For example, I can say this item is around 3 logits difficult. You see, it's 3, around 3, around 3 logits difficult. And this person is also around 3.5 logit able. And this is very interesting because we are putting people and items on the same map using the same unit, which makes the analysis and specifically the comparison between people and items much easier for us. Something else about this map, which I have already highlighted here, is this table. You see there is a gap. Actually, the table could be larger. Let me say highlighter, pen. Sorry, I cannot find it. Right. Okay, clear. Okay, so just cleared it. Go back here. You see, this is a gap, meaning that for these people, there is no item here to match their ability level, right around, let's say, their ability level, which should be here. We don't have any items around here. So, in other words, it could indicate that the construct that we have operationalized might have been underrepresented because there are not enough items here. This is one way you could interpret it. Or it could be that the items could be improved, or it's just the quality of the items. I mean, it depends on how you want to interpret it. Maybe you need to add more items here in order to fill in the gaps and in order to measure the ability level of these people more accurately with more precision. Later on, I will show you, if you look at the standard error of measurement for these people, it should be pretty high because there are not enough items in their around their ability level to measure them with accuracy. So this is item person map. Actually, you've got different versions of the same map. If you go down, I want to scroll down here, you have similar thing here. You see, items and persons have been arranged on both sides, and further down you see here you got the names of people, kids on the other side. You've just flipped them around. Anyway, so this is how you can roughly interpret item person map, or the right map of Rasch measurement. So I'm going to close this and go back to our output tables, right click, and just click on entry. What we are provided with is, again, this map, or this table if you will, with quite a few options. So let me just go through some of these options. This is this is our entry number, item number 1 through number 16. Okay, and you've got mean and standard deviation of per each item, per each column here. I mean, if it applies really. For example, the total score on item number 1 has been 35 out of 35 attempts, meaning that 35 students or 35 people attempted item number 1. Let me just underline for you with a different color here. Okay, 35 students total count attempted to answer the question, and all of them got it accurately, got it right. What does it mean? It means that the item is quite easy. That's why all students answered it accurately. What does that mean? It means that we expect to see it right at the bottom of the hierarchy of difficulty, which is right here. Let me just can I highlight it? I think I want to use highlighter. Is it highlighter? Okay. So I want to oh, it's not a highlighter. Sorry. Gosh. Anyway, so I have difficulty finding the right option, but don't worry. It's just because I'm using this feature. I've began to start to use this feature just today. So I want to underline this for you. So as you see, minus 6.59 logis, which is very low, basically at the bottom. Now the second, so these guys are all the same. These items are all the same, 1, 2, 3 in their difficulty level. Item 4 is the second most easy item, or the second easiest item, if that's the right way of putting it, because its measure or its logit is minus 4.40, because 35 students attempted to answer the question, whereas only 32. Actually, 32 is quite high too. So this is a lot. Now there is something else in this map. Is the model standard error of measurement. SE stands for standard error of measurement. Let me just highlight and just put it in this box here. The lower the standard error of measurement, the higher our confidence in the measures of those items. Why is the standard error of measurement is so high here? Because technically it has been so easy that all people answered it accurately. So when an item is minimum or maximum measure, like this one at the bottom, or these 3 items at the top, we expect to have a very high standard error of measurement, because not many people at the same ability level or corresponding ability level attempted this item. If this item was answered, for example, item number 1 was answered by quite a few people with minus 6.59 logits of ability, this standard deviation, the standard error of measurement would decrease, would go down. However, those items, for example, like this one, where we've got 0.45 of standard deviation, this is the lowest. Why is this so? Because 35 students tried to answer, but only 12 were accurate. It means it was of around medium difficulty or slightly above the midpoint. You see the midpoint, if you take the average as a midpoint, which was 0, if you recall, in the previous map, 0.79 is just around less than 1 logis above that. So that means that this item is around medium difficulty or more than medium difficulty. And as you go down this hierarchy, you see that the difficulty begins to increase, so much so that item 18 has not been answered by a single soul. That means we have a great amount of error of measurement, which is 1.84, as you can see here. And therefore the measure is 6.13 logits, which is quite high. The other thing I would like to highlight for you quickly is, let me just choose, let me just clean, okay, and choose a different color. How about yellow? Okay, is outfit and infit. All right, so just let me highlight them for you here in this box. Right, so outfit and infit. Let's get started with infit. Infit is an inlier sensitive quality control statistic. What does that mean? It means just imagine a range out of which the item does not function the way that we want it to function. And that range is basically different. I mean, different scholars would say different things. For example, Dr. Mike Lineker himself suggests 0.5 to 1.5. There are other notes on winsteps.com, which I suggest that you read. For multiple choice questions, it's basically 0.8 to 1.2, which is a more stringent range, more stringent than the liberal range proposed by Dr. Mike Lineker himself. But of course, you can just specify your own range. There is no one golden rule here. So let's say this one, item number 4, whose infit mean square, MNSQ means mean square. Okay, this MNSQ. It ranges from 0 to infinity. Technically, you never reach infinity, but as long as you're around 1, I just put it very roughly, as long as you're around 1, it should be fine. So these two are good. I would still accept this one. 0, so I'm going to choose a different color here. 1.33 is a bit off. These guys are good, so I'm going to choose the same color. It's not too bad. Basically, they're approaching 0.5, but it's still okay. I mean, this is approaching what we technical called overfit. Overfit is not a big issue. Underfit is. Underfit is, for example, let me see. This one could be an underfit, meaning that we hear more noise than music in this item. It could be due to its difficulty level, or it might be that high ability students missed it, or low ability students just accidentally answered it accurately, or just performed well on it. A few low ability students performed well on it because as you see, it's a highly difficult item. Only 3 students answered it. And if, let's say, one of these 3 students is not a very able student, this is odd, because how come a less experienced or an average student or poor student in terms of the ability that we want to measure answered a difficult item accurately? It's a bit unexpected. So this unexpected event will be captured by Infit mean square value. Outfit is an outlier sensitive sort of statistics. What does it mean? It means that it captures abnormality or anomalies which are far away from item difficulty. Okay, so again, the same thing applies. 1.49 is again, not very acceptable. This one is really off. So there is a problem in item, what number is that? Item number 7. And then the rest of these are, it's like correlations of the item. Of course, this is not estimated for the minimum measures and maximum measures. As you see, it's always 0. But it's the the correlation of that item with the entire group of items. And the correlation and expected are supposed to be close to each other, not too far away. And in most cases, we've got that. So this is another piece of quality control assurance. But you see, in this misfitting item, they're a bit farther from the rest of the items which are fitting about okay. And this, I will elaborate on this column because it needs further elaborations in another video. And here we've got mean and standard deviation of most of the statistics here. For example, the measure has got the mean of minus 0.76, whereas the standard deviation is 4.26, which is quite high actually. So this is how you interpret this table, and I'm going to just erase everything and just go further down here. And as you will see, we have got similar options, but with a similar table, but with more information about the data that we have used, which I will elaborate on in another video, because this video intended just to let us know how to run the program and how to make sense of 2 of the basic outputs from Winsteps or Winsteps. Thank you very much for your attention. I will try to, in a second video, try to upload, give you some information about where to find which links, the links that I just mentioned, and how to use other output tables from Winsteps. Thank you.